All right, so today is the last day on 11.1, which is exponential functions. Today our focus is going to be on application. So in other words, we're going to be doing word problems with exponential functions. Now, in order to do word problems with exponential functions, there are actually two equations that you're going to need to know. The first equation is a equals p 1 plus r over n to the nt. Now you're going to need to memorize this formula because you're going to need to know it for the quiz, for the test, and it won't be given to you. So you need to make sure that you memorize it. Okay? And this formula is used whenever we see things like interest being compounded, right? So compound interest is what this is for. Specifically, it's interest that's compounded on set amounts of time. So this general equation is used for compound interest for set times. What I mean by that is, if we say that it's compounded monthly or annually or semi-annually or anything like that, if I tell you how it's compounded and it's based on a set amount of time, like once a month, twice a month, 3 times a year, 4 times a week, whatever, then we're going to be using this compound interest formula because it's a set amount of time. The A stands for the final amount. In other words, what you have at the end, right? So if I put my money in an account, whatever I have when I take it out at the end is your A. The P stands for principal. And the principal is really an initial amount. So you could think of it as initial or a starting amount, so how much you put in to begin with. The R always stands for rate, and rate will be a percentage, right? But you need to change it to a decimal before you put it into the formula. As always, you can't put percentages into equations. N stands for the number of times per year. What I mean by that is how many times per year is it compounded. If it were monthly, the N would be 12. If it were monthly, the N would be 12 because there are 12 months a year, so it would be compounded 12 times a year. If it were weekly, it'd be 52, so on and so forth. So that's what I mean by N for the number of times per year. And T is always time, and it must be in years. And this is really important. If it's not in years, you're going to have to change it to be into years before you can answer the question. Now, some keywords that we have over here. And these keywords tell you the number of times it is compounded per year. In other words, these are the indicators of what your N, is. So quarterly means 4 times per year, so our N would be 4. Semi-annually means twice per year, so 2 times per year, so your N would be 2. Monthly would be 12 times per year, since there are 12 months in a year. Daily would be 365 times per year. Okay, and these all represent the N because the N talks about the number of times per year that it's compounded. All right, so let's do an example problem. So looking at example 1, you invest $15,000 in an account that pays 8% interest rate compounded monthly. How much will you have after 18 years? So, because I know that it's being compounded monthly, I should automatically realize that I'm using the formula A equals P 1 plus R over N to the NT. So now I have to decide what each one of these things are. So if I'm investing $15,000, that's going to be my starting amount. So that really is my P for my principal. So I know my P is $15,000. My A was the first letter. I don't know what that is, so I'm just going to write that down. 1 over, and then we have an R. Remember, R was rate in a percentage, so this is my rate, but we're going to change it to a decimal, which is 0.08, because remember, you need to move the decimal twice to the left to get rid of the percent sign. Now I need to look for the N. Now remember, N was the number of times per year. So monthly is how many times per year, and since there are 12 months in a year, my N is 12. And again, still 12, and then T stood for time, and remember, time must be in years, and here we have 18 years, so my T is 18, so I can just go ahead and substitute in. I don't know my A. My P is 15,000. 1 plus 0.08 over 12 to the 12 times 18. Now, a lot of times I'll put that in parentheses so that I remember that all of that is an exponent, and then I can just go over to my calculator to type this in. So we're going to clear this out. 15,000 parentheses 1 plus. Now, you could either do another set of parentheses to make this into a fraction, but to me that's really confusing to type into your calculator, so I'm just going to use that fraction button. So it's 0.08. Arrow down, divide it by 12, close my parentheses, to the power of 12 times 18. And we get A equals 63008.61281. Now, because we're talking about money, it shouldn't make sense to go all the way to the end. We should only go till 1 after the decimal. So this 2 makes this 1 stay a 1. So my end answer is really the $63,008.61. But since it's a word problem, our answer must be in words. So how much do you have after 18 years? After 18 years, and it's important that you put that because if it were a different amount of time, it would be a different number. So after 18 years, you would have make sure you put your dollar sign, $63,008.61. Okay? So what I recommend is that you pause. No, you can pause and try number 2 on your own and then check it with me in a moment. Or you can go ahead and watch it, but if you pause, that'll give you some extra practice. All right, example 2. You deposit $500 in a savings account that pays 6.25% interest compounded daily. How much will you have after 10 years? And then there's a second one for after 25 years. And then there's a third one for after 100 years. So we're going to do these in 3 different sections. We're going to do one of them that's for the after 10 years. We're going to do one of them that's for the after 25 years, and we're going to do a different formula for after 100. So there are actually 3 problems in this one problem. The basic formula is still the same though. Because it is daily, that tells me that we're going to use that base formula, A equals P, 1 plus R over N to the NT. Now, a lot of these things stay the same. So it says you deposit $500. Well, that's a starting amount, so that's my principal. So my principal on all of them will be $500. Then it says in a savings account that pays 6.25%. Well, that percentage is a rate. Remembering that we have to move it over twice means my rate is 0.0625. Daily is how often it's compounded, so my N is 365. Now my T will be different for each one. So I'm just going to put it will differ. And then we'll do 3 different problems. So I'm going to start out with the 10 years. Okay, so for 10 years it would be that means that my T is 10, right? So A equals, my P is 500. 1 plus, my R is 0.0625 over my N, which is 365, as it will be for all of them. And again, to the 365 is N times my T, which in this case is 10. So then I'm going to have to get out my calculator and go ahead and type that in. So we have, oops, I'm covering up part of my formula here. So 500 parentheses 1 plus, use my fraction button, 0.0625 over 365. Oop, didn't need that parenthesis, so we'll delete that. Arrow out, parenthesis, to the 365 times 10. So I ended up, for the 10 years, I got 934.073. Well, that 3 would make my 7 stay the same, so $934.07 after 10 years. And that answers the first part, but now I need to go and do the second one, which is 25 years. So in this case, my t will be 25. So it's going to be basically the exact same formula. The only difference is that my time is going to be 25 instead of 10. So the only thing I need to change here is that this is times 25 instead of times 10. So when I pull up my calculator, to be honest, I can just scroll up, press enter. It'll copy the exact formula down, and then the only thing I need to change is instead of 10, it is 25 for time, which gives me $2385.0, not 4, but 5, because the 7 makes the 4 become a 5. So it's $2,385.05 after 25 years. And that's the second one. And then I need to go ahead and do the third one, which is 100 years. So A equals 500, because remember this base problem is still the same rate, still the same amount of times compounded. The only difference is now instead of 10 or 25 years, it is 100. So I'm going to do that same thing on my calculator just to make it go quicker. And now I'm going to change 25 to 100 and make sure I close that parenthesis. And we would get $258,867.87 because the 0 makes the 7 stay a 7 after 100 years. Okay, so that's the formula that we use if there's a set amount of times that it's compounded per year. Now there's another formula that we're going to use, which we'll talk about in the next video.